Welcome to our next lesson in Math 8, Unit 4, Lesson 4. I really like today's lesson because today's lesson is a really important skill that's going to help us out for a very, very long time in math. So pay close attention today. Pause, rewind, rewatch. Do all these different things to make sure you understand this concept today. We will see it more down the road, but today is our introduction. This is called More Balanced Moves. We're going to rewrite some more equations, but the key thing is we're going to keep them balanced. And we are going to make sure that we understand what it means to have the correct solution. How do I know when I have the right answer? Here we go. Equation number 1. Which of these have the same solution as equation 1? Be prepared to explain your reasoning. Well, going from equation 1, let's just talk about the way that we could do this. One way we could do this. When we see x minus 3 is equal to 2 minus 4 times x. The very first thing that I like to do personally is I like to collect my variables into one expression. By doing this, I notice a lot of different things that we haven't talked about yet, like how many solutions the equation could have. But it also helps me to isolate that variable in a way that makes it look more familiar to me. I see that I have a positive 1x over here, and a minus 4x over here. If I add the opposite, that gets rid of this value, or it undoes this value. So when I see subtract 4x, if I add 4 times x to this expression here on the right, that eliminates that 4x here. But to keep equality, I have to add 4 times x over here, and I have 5 times x minus 3 is equal to 2. And you'll see, hopefully it looks like something that's more familiar to us, where we see just one variable, or variable on just one side. At this point, I can collect my constant values, meaning my values without a variable attached. And I add the 3 to eliminate it from this expression, add the 3 to combine it with this expression and maintain equality, where I'm left with 5 and the expression on the right, 5 times x with the expression on the left. I'm going to bring this over here to finish it. 5 times a number is equal to 5. Well, I know in multiplication, I have 2 different options here. The more traditional option that we will see is, since we see multiplication here, we can just divide by the coefficient of 5 on both expressions. That gives us 1 for this one, and 1 times x we know is x. And 5 divided by 5 is 1. Another option is we can multiply by the reciprocal. We know that the reciprocal is when we take a fraction and we turn it over to be an inverted option of it. And then what we see is the same thing. 1 times 5 is 5. 5 times 1 is 5. And then I take the reciprocal of 5 on the other side. I get the exact same outcome of 5/5, or I just know x is equal to 1. Okay, that'll come in handy, especially when we're dealing with coefficients that are fractions. So let's take a look at equation A, B, C, and D, and see if they're the same thing as equation 1. And to be honest, we won't even have to solve these all the way. We just have to understand what has happened to them to see if this equation is still equal to this equation. The very first thing I'm going to do is compare the expression on the left, and I'm going to look at each of these terms to see what has happened. I see the first term has gone from x to 2 times x, and then a minus 3 to a minus 6. What I recognize from that is it appears that this equation right here, x minus 3, or that expression, has just been doubled. So I get twice the value of x minus 6. Let's see if the same thing happened on the right side. I go from 2 to 4 and a minus 4x to a minus 8x. And I see the exact same thing has happened, which means that this equation A, is exactly the same as equation 1, because I multiplied by 2. Just doubled each of the terms in the expressions. The next one, equation B, what's different here is I see that the minus 4x on the right side is still present, but the 2 is gone. I see the x is still the same on the left expression, but the 3 has turned to a 5. Well, what I know about this is if I take that 2 away from the expression on the right, and I can do an add the opposite, add -2 to it, and if I add a -2 to a -3, I do get a -5, which means that, again, expression or equation B is the same as equation 1, and we do this by adding -2, or we can just simply subtract 2 from either side. So these are the exact same things. Add -2 or subtract 2 are the same exact options. Equation C, boy, this one looks a little different, but the first thing that catches my eye is this. I see the x minus 3 expression is now over here on the right side. So I'm wondering if they're just trying to trick me into thinking, hey, it's totally different. I want to look at equation C in this expression on the left and compare it to 2 minus x, or minus 4 times x, and try and think, how could they have done this? Is it possible? If I go ahead and distribute this back out, 2 times 1 is 2, and 2 times a minus 2x is a 4x minus 4x, and I see that I have the exact same expression as the original equation. Just simply they distributed this down, or they did what's called factoring. They factored out a 2 from this expression to make it look a little different, but it really has the same value. So we would say factor out 2, or we do the factoring in this case by divided by 2 in 2 minus 4x. Okay, last one, equation D. I see a minus 3 and a 2 minus 5x. You know, this one kind of looks like it's a step further than where we were at in equation B. But let's try, and it kind of looks like this one. So let's see what happens up here. If I started out with x minus 3 is equal to 2 minus 4 times x. And over here, I'm left with a minus 3. I'm left with the same positive 2 here. It appears that this x has been eliminated because this x is here. How could I do that? If I subtract x from this side and subtract x from this side, a minus 4x minus 1 more x would give us a minus 5x. So in this case, I just said minus 1x, and that gave us the exact same equation. So what we know is A, B, C, and D, all of them have the same equation, or same solution as equation 1, because they're just different versions of it. We've used some inverse operations to change the equations just a little bit, and they're the exact same. So kind of neat to see a lot of different steps. In the beginning, when I introduced this video, I told you that we were going to find out, how do I know if I have the right answer? For a long time, I think that we've kind of just guessed. In this case, when we talked about this, the right answer, and these, you'll notice that we talked about the solution, right? Same solution right here. We talked about right here, let's write some more equations while keeping the same solutions. The solution to the equation is this. A solution is the value of the variable that makes the equation true. So it has to make that equation true. If the equation comes out false, then we know that we have the wrong answer. So let's do this one very first off. Claire and Lynn both solve these equations. These are all of their steps. And you see at the very, very end, this last one right here is the solution. So Claire and Lynn both have the same solution. We have minus 8 is equal to x, and x is equal to a minus 8 or a negative 8. So the question is, are both of their solutions correct? This is kind of nice because what I can do with this is I can follow their steps to decide, did they do the right thing or not? Or I can simply go back and find out, is negative 8 really the correct solution to this equation? The way that I determine that is through substitution. By using substitution, we take our value of x is equal to negative 8, and we substitute or plug it back in wherever I saw an x in the original equation. We see that they were both dealing with the same equation, and in that original equation, we see 14 times minus 8 minus 2 times a minus 8 plus 3 is equal to 3 times the sum of 5 and negative 8 and 9. Now, if this becomes a true statement where this expression here on the left simplifies to the exact same value as the expression on the right, then negative 8 is the right answer. So the first thing we want to do, I don't know 14 times negative 8 off the top of my head, so let's find that real quick. Is a minus 112. I do know that 2 times 8 is 16, and a negative times a negative is a positive, plus 3. So negative 112 plus 16 is making this number get closer to 0. So we're going to add 16 to that to make negative 96. And then we'll add 3 more to make a negative 93. Now, this is just simplifying the expression. I have not found out totally yet if x equals negative 8. So let's go to the right side. I see 5 times a negative 8 is equal to a minus 40 plus 9. And then I'm going to multiply that by 3. And so I have negative 40 plus 9 would give me a negative 31 times 3. So let's go 3 times negative 31. I get negative 93. Now, when I look at these, we've maintained that this expression and this expression is equal to each other, and we've said it's still equal, and at the very last line, we've proven that these two equations or these two expressions are equal to each other, which means that negative 8 is the correct solution. And how do I know? Explain your reasoning. Since 14x minus 2x plus 3 equals 3 times 5x plus 9, then x equals negative 8 is the solution. Cool thing about math is I can write mathematical sentences as an equation, and then here's my evidence right here that I've proven that wherever I have an x is a negative 8, it simplifies out to the exact same value in each expression. The solution, the answer is not negative 93. That's just the way that we prove that negative 8 is really the right value for x. Couple different steps that we see that look a little different, a little alike. I see right here in step 1, they start out with the same original equation. It looks like they use the exact same step in the first equation where they just simplified the 14x minus 2x to get to here. The third step, we see 3 times 4, the sum of 4x and 1, which means that they factored out from the 12 and the 3. This is the opposite of the distributive property. So it's still distributive property, but it's factoring. They factored out a 3 from this side so that the two expressions kind of look alike. You'll see that there's a 3 times this expression and a 3 times. And then they were able to divide by 3 on both sides to eliminate that 3 and just be left with 4x plus 1 and 5x plus 9. Where over here, what Lynn did was multiplied by 3 instead. She applied the distributive property to get 15 times x plus 27. The next step, then we see just differences down until we get to our solution. The next step, Claire subtracted 4x to get x by itself on the right side, whereas Lynn subtracted the 3 from the left and from the right. And then for the very last step, Claire had to subtract 9 from both sides, and Lynn had to subtract 15 from the 12x, and then it was a matter of dividing by the coefficient that was left. So pretty cool to see how they can work the exact same equation a couple different ways, get the exact same answer. And the biggest thing is know for a fact that their answer is correct. All right, let's look at our next two. This is a really important skill as well, is where we have Maya and Noah, and maybe it's May. I don't know exactly how to pronounce that name, but They've solved an equation, but this one we know that there's some errors. So we're going to find those incorrect steps. It's really important that we can identify these errors for ourselves so that when we don't get the right answer, we can find where we went wrong, and then we can make that mistake, or we can repair that mistake. So let's take a look. Here's the exact same equation that we just saw in the previous problem. Let's see what they did here. Let's start with May here on the left. 14 times x minus 2x plus 3. Let's just look at this expression here on the left. Is 14 times x minus 2x equal to 12x? It sure is. So this part is good up to right here. Let's look at the right side. Nothing wrong there. First step, good job. Next step, we see that 12 times x plus 3 turns into 7 times x plus 3. And then 3 times a 5x plus 9. And it just turned into 9. So how exactly did you get that? Well, it looks like if I'm looking at the square correctly, I know that 12 minus 5 is 7. And here's the error, one, or at least the first error right here. We can't just simply subtract 5x out of here like this, because it's part of a grouping. That's not just 5x in this expression. That's 3 times 5x, which is really 15 times x. And by getting that value wrong from the beginning, that really messes it up down the road. Let's see if she made any more mistakes. From here, we have 7 times x plus 3, and 3 and 9, 27. She subtracted 3, which would be 24. 24 divided by 7. So really, she actually did really well. Her mistake was right inside here. Not necessarily this step right here, but right here in this step. What I would tell May is saying, hey, you have to distribute before you start using subtraction. Kind of like following the order of operations. We need to do that first. Or she could have divided by 3 first. So I would say this, May, in step 2, I would say either divide both expressions, whoops, no E on the end of both, by 3 first, or distribute the right side first. Either one. Okay, she should have done one of those first. Well, let's look at Noah. Noah goes from 14 times x minus 2x plus 3, 12x plus 3, good. Distributed here, 3 times 5x is 15x, 3 times 9 is 27, beautiful. And then somehow we got 27x over here. How did we get that? I think that what Noah did is added 15x here, but here's the question. What happens, what is 15 times x plus 15 times x? That right there actually equals 30 times x. So there's a mistake right there. Let's see from here if he knew what he was doing on the rest of them. From the plus 3 to 27, he got to 24. That is a minus 3. Awesome. So for the rest of it, he's still got his steps right. But what I would tell Noah right here, Noah, in step 2, subtract 15x, not add. Problem is it does not eliminate over here. He thought he eliminated, but he really didn't. All right. Sorry, this lesson is getting a little bit long. Let's actually practice this on our own with some equations that may look a little complicated, but I promise you there's some simpler strategies that we can do with these. The first one, we see a couple of fractions. Before you start panicking about fractions, let's look and say, can I simplify them? The expression here on the left, there's a little bit that we can do with this one. Let's take a look. 12 plus 6 times x, and 12 and 6x are both being divided by 3. Well, that's kind of cool, because I know that 12 divided by 3 is 4, and I know 6 divided by 3 is 2, so 6x divided by 3 is 2 times x. And then these two would just be adding. Now, so before I went ahead and got scared about this, I need to look and see, can I simplify the expression first? Same thing over here on the right, 5 minus 9 is a minus 4 divided by 2, and a negative 4 divided by 2 is a negative 2. And what started out as looking like a very complicated equation actually becomes somewhat simple because of the simplifying that can happen here. So don't be afraid of the equation right out the gate because it's a fraction. Look to see, can I simplify first? And so from here, subtract 4 on both sides to eliminate it. And we have 2 times x is equal to minus 6 divided by 2 on both sides. X should be equal to a negative 3. And I can just double check my work on this to make sure that I'm right by going through and substituting negative 3 back in. We'll go ahead and let's look at this, and we're gonna shortcut this a little bit with a calculator. I know that 6 times negative 3, I'll be looking at this, 12 plus 6 times negative 3 divided by 3. And I need to make sure that that is equal to a negative 2. 12 plus 6 times negative 3 is negative 18, which equals negative 6. And negative 6 divided by 3 is sure enough negative 2. I know both expressions are equal to each other because this expression on the right turned into the exact same value, did it? It sure did, because this expression turns into a negative 2 as well. So I know that's right. Let's look at number 2. I see that I have a fraction again. Oh no, let's not panic. Can I simplify the expression? This one here on the left, I can't it doesn't get any simpler than x minus 4. I know that 1/3 of 6 times x, 1/3 of 6 is 2. And so that one would simplify down to 2 times x. Now, what's 1/3 of 54? Well, I know that 54 can be divided by 6. So I'm thinking it can be divided by 3 as well. So 54, I know it's a negative or a minus 54, times 1/3. My calculator doesn't make the fractions, but I know that multiplying by 1/3 is the same thing as dividing by 3 is a minus 18. And now I'm left with an opportunity to go ahead and just solve my equation. I'm going to start with my variables because I like to collect those ones first. Eliminate the x from the left, subtraction property of equality. Now here's the thing that we want to look at. See how I took away that x? Look what's left. Don't forget that minus sign because that's critical for the next step. 2 times x minus 1x is an x minus 18. And then I would add my 18 to eliminate it and add 18 here. A minus 4 plus 18 is a positive 14 for x. And now I want to make sure that I'm right. 14 minus 4 is equal to 4. 1/3 of 6 times 14 minus 54. Let's get the calculator again. 6 times 14 equals, whoops, I must hit the wrong button. 6 times 14 equals 84. 84 minus 54 is 30. And then 1/3 of 30 is going to be 10. I see where I made my mistake. 14 minus 4 is not 4, silly. That's 10. Pay close attention to what you're doing because maybe the mistake is not with the answer. Maybe the mistake is in my check. And I would have thought, oh, 4 isn't equal to 10. 14 is not the right answer. No, I made a mistake. I see that 10 is equal to 10. When I had 14 for x, both expressions simplified down to 10. I know that I have the right answer. Final one. Let's look here. Let's go ahead and simplify before we get started here and see what we can grab. I have a negative sign. Ooh, look at that little negative out there. How does that change this expression here? Well, that means take the opposite of what we see. So instead of a 3x, I would get a minus 3x. And instead of a minus 12, I would see a plus 12 is equal to 9 times x minus 4. Now, a lot of options that I have here, a lot of routes that we could go. Again, I personally like to use the variables first, but I'm going to show you a different way because that's just what I'm going to do. So with this one, let's just start out here. We'll go ahead and subtract 12 from this expression here. leaving us with a minus 3x. And then that means that I need to subtract 12 from the constant on the right, which leaves us with 9 times x. Pay attention to this. A minus 4 minus 12 more is minus 16. It's the same thing as adding negative 12 and adding negative 12. And now I have to combine my two variables. So now I need to subtract 9x from this expression on the right to eliminate it. Leave me with just, again, pay attention here. That's a minus 16, not a positive 16. And then subtract 9x from here. And maybe this is a little confusing, so we'll go ahead and say this is a plus negative 9x. Again, this is the exact same thing. Subtracting 9x is the same thing as adding a negative 9x. And a negative 3x plus a negative 9x is a minus 12x. I want to divide by 12, negative 12 on both sides. And this isn't going to be very friendly, but we're going to find out if I'm right. Negative 16 divided by negative 12, those both have a common factor of 4. And so if I just simplify, divide by 4 on the top, that's a 4. Divide by 4 on the bottom, that's a 3. And I know that negative divided by negative is a positive, so I think that x is 4/3. All right, let's find out if I'm right. Negative, or the opposite value of 3 times 4/3 minus 12 is equal to 9 times 4/3 minus 4. Now, it's kind of tricky when I'm multiplying a number by a fraction that's not another fraction. So let's take 9 and turn it into a fraction of 9 over 1 and 3 over 1. And then 3 times 4 is 12. So that's like 12/3, which makes that actually 4. And I know 4 minus 12 is a minus 8. But I have to take the opposite of that. So this expression here on the right, forgive me, I'm going to write it up here as positive 8. Over here, 9 times 4 is 36 divided by 3, which is 12. And 12 minus 4 is also 8. Oh my goodness, I'm so happy that 4/3 is really the right answer. I know it's the right answer because when I substitute it for x and x, I get 8 is equal to 8, meaning that both expressions simplify down to the exact same value, which tells me I did the right work. I got the right value for x. Whew. Okay, I know this is a really long video. Pause it if you need to for a minute, rewatch something, take a break for a second, come right back. I'm going to do this last problem and then we'll close it up. On this last problem, it says I have 24 pencils and 3 cups. Okay, that's important. The second cup holds 1 more pencil than the first. The third cup holds 1 more than the second. How many pencils does each cup contain? Wow. Well, let's look at this. The variable is this. I don't know exactly what I'm working with yet, but I do know this. I know I have 3 cups, so I'm going to use C for cups. I have cup number, or I have a cup plus another cup plus another cup, and I'm looking at 24 pencils total, right? 24 pencils and 3 cups. So that's going to be equal to 24. Let's go back to these cups. If this is cup number 1, cup number 2, cup number 3. So the second cup holds 1 more pencil than the first. That's going to change this one right here to the cup 1 plus 1. So this one right here, cup 2, is really going to be C plus 1. And cup 3 holds 1 more than the second. So that one is really going to be, this is the value of cup 2 plus 1 more pencil. So I've gone from the first cup, which then to the second cup has just 1 more than the first. And then the third cup has 1 more than the second cup. A little bit challenging, but I think it's manageable. And I know that that is equal to 24. So now what I get to do is I get to simplify. I see that I have 3 values here. Let me get rid of that. So we know that that's just where we started, where we started building our foundation and where we had to change it. I have C, C, and C. I have 3 C's that are all added together somewhere in here. And I have 3 1s, which makes that 24. And then I can start solving. Subtract 3, subtract 3. 3 times C is equal to 21. I know 21 divided by 3, C is equal to 7. Let's just double check this to see if I'm right. I know that if I'm talking about in 1 cup, I have 7 pencils. In the next cup, the second cup holds 1 more than the first. That's C plus 1, or 7 plus 1, which is 8. And then the third cup holds 2 more, or holds 1 more than the second cup. So that's 8 plus 1 is 9. 7 plus 8 is 15. And 15 plus 9 is, in fact, 24. How many pencils does each cup contain? The cups contain, first cup has 7, second cup has 8, third cup has 9 pencils in it. And I would write that in a sentence form. Whew, thanks for sticking in. This one took a little bit longer for the lesson. I know you're probably saying they all take a long time. Yeah, they do. But the cool thing about this is, how do we make sure that the solution we have for an equation is correct? Is we make sure that we made all the right steps first off. Accidentally adding or subtracting, like when we meant to subtract, or missing a little negative sign, or not distributing first, or doing some little pieces like that, they make a little teeny tiny mistake, makes for a bigger mistake later. So we really have to watch out for those little mistakes. The way that we can know if we did it right, though, is by substituting our answer back into the equation. So fortunately, every step that we take means that we can check our work and go back to make sure that we did the right thing. Here we see on this page step-by-step instructions for that substitution, with some commentary to make sure that we understand about why an equation is true. Don't forget that at the very end of checking my work, my expressions have to simplify down to the exact same value. And when they do that, then we know for a fact that the value that we think x is equal to is the true statement. So thanks for hanging in with me today. Again, I know it's kind of a long video. I really appreciate your hard work. Let me know how I can help. Have a great day today.